Okay, good to see everyone. So today we're going over experimental design. How do different variables affect each other when we're trying to record different experiments? So how would we do replication? And we're going to do that through Simutext, the app that you should have downloaded onto your own desktop right now. And this is probably one of the few times where your lecture material is probably going to be in sync with lab. So that's exciting. I guess from here, yeah, nobody has any problems downloading Simutext. Everyone has it on their computers. Thumbs up. Thumbs up. Okay, awesome. Awesome. So let me share my screen then. So when you log into Simutext, the very first page, the home page that's going to take you to, you're going to have Isle Royale and Understanding Experimental Design. So this is the lab that we're doing today. Isle Royale is for in 2 weeks, for lab 3, because we don't have lab next week because of President's Day. So if we click into Understanding Experimental Design, it's going to take us to this first exercise that we're going to go through. So first of all, the layout for lab today, I am going to break you all into breakout rooms in around like 3 groups or 3 people in the group. And then I'm going to give you maybe 20-25 minutes to go through exercise 1. We'll come back to the main room, and then I'll go through a case study, breaking down a few variables, few different terms, and then you're going to go back into your breakout rooms for another 25 minutes and then do exercise 2 again with your groups. And that would be another 20-25 minutes, and then we're going to come back, discuss, and that would be it for this lab. What's due for this lab is finishing these exercises through Simutext. It tracks your progress as you go along based on your own individual account. So when you're done with these Simutext exercises, that's all that's due for this lab. There's no like report that you have to do after this. So you're just going to be doing the Simutext 2 exercises. And yeah, okay, so I am going to now put you into breakout rooms. Or actually, let me bring you back to Simutext and go through a few slides to show you what it would look like. So we have our section 1, section 2, section 3. We don't have to do section 3. We're just doing these 2 sections. So the very first breakout room in the 25 minutes, we're going over section 1. So if you click on the top arrow, there's background information that you can read up on. This video that I've linked in an announcement if you watched it, it's the exact same video here. And it's going to go through a few background information, just like what does it mean to use a scientific method. And if you've gone through it, this is the process for that. There's a few questions that you'll answer along the way, and it'll tell you if it's right or wrong. You'll check your answer. You can just keep on testing out until you get the right answer. So really, that's basically it for section 1. There's around 16 slides and a couple of questions that you'll answer with your group. So from here, let me put you into your breakout rooms. I will see you all in 25 minutes, so say at around 9 o'clock. Okay. Let me just share my screen. So to go over a few definitions and a case study, I am just going to read this class exercise. A university professor notices that students who take lecture notes on their laptops tend to perform worse in her class compared to students who take notes by hand. She hypothesizes that the act of taking notes on a computer leads to reduced retention of information compared to taking notes by hand. To test her hypothesis, she recruits 50 undergrads from her institution to take part in this study. Participants are randomly assigned a note-taking strategy, either by hand or on a computer. They are led into an empty classroom and are instructed to take notes as they watch a 15-minute pre-recorded lecture. The following day, the participants are asked to return and are given a quiz on the content of the lecture. So to go over a few definitions for our first question, which of the following is the independent variable in this experiment? So the independent variable is the factor that we change. It's also known as the treatment variable. So it's the variable that we manipulate. And if we look at the options we're given, note-taking strategy, the lecture students watched, quiz performance, and the number of participants, we can say that quiz performance, that's something that depends on how students do on the quiz, the number of participants. It doesn't vary. The lecture student watches that the students watch, that doesn't change. So we can say that A, our note-taking strategy, is our treatment variable, our independent variable. So it's either taking notes by hand or via computer. For question 2, which of the following is the dependent variable in the experiment? So the dependent variable is the variable that we look at to measure the experiment's outcome. It's the outcome variable. It depends on the independent variable. So what are we measuring at the end of this experiment? Again, we're given the same options: note-taking strategy, the lecture students watched, quiz performance, and the number of participants. So we can take out a note-taking strategy because that was our independent variable. And we can also say that looking at the number of participants, it doesn't change. It doesn't depend on our note-taking strategy. The lecture student watch doesn't change. So our quiz performance would be our option C is the answer, because how students do on the quiz depends, would be our dependent variable, and that could change based, or that's what we're measuring based on our note-taking strategy, our independent variable. Question 3, what are the experimental units in this experiment? And experimental units are the subject of treatment. What are we applying our treatment to? What are we applying our independent variable to? So if we're looking at the same options again: quiz performance, note-taking strategy, the lecture students watch, or the students, we are applying our independent variable, our different note-taking strategies, to the students watching these lectures. So we can say that D is our answer. So D, the students are our experimental units. Which of the following potentially confounding variables is least important for the professor to hold constant? So confounding variables are, they're held constant to make sure that we're not interfering with our experiment's outcome. And so if we were trying to hold certain variables constant and we're looking at these 4 different variables, which would be the least important for us to worry about? For A, the lecture the students watch. B, the amount of time between watching the lecture and taking the quiz over the material. C, the temperature of the room in which students watch the lecture. Or D, the clothing students wear to watch the lecture. So for option A, the lecture that the students watch, it's if we changed this, then our quiz performance would probably vary. So we would want to keep the lecture that the students watch constant. So that's pretty important. So we will not count A. For option B, the amount of time between watching the lecture and taking the quiz over the material. If one group takes the quiz the next day and the other group takes the quiz a week later, that could change their quiz performance. So we would want to keep the amount of time between watching a lecture and taking the quiz the same for both groups. So we wouldn't want to change this, and that's pretty important. So we can take out B. The temperature of the room in which students watch the lecture, unless it's really hot or really cold, we don't really have to worry too much about that. So for that would mean that our answer is D, the clothing students wear to watch the lecture. So if you're a researcher for this experiment, you probably wouldn't want to put a lot of time or money into controlling this part, controlling what they wear. So the least important confounding variable would be the clothing students wear to watch the lecture. So D. So for question 5, which of the following ideas for increasing replication is most likely to improve the ability to test the hypothesis that taking notes by hand leads to better retention of information compared to taking notes on a computer? So what we want to say, if we wanted to increase replication between these 4 different points, which would be more likely to give us an improvement of our overall study. Our 4 options are to increase the number of students assigned to both note-taking strategies, to both either note-taking by hand or via computer, increase the length of the quiz that students take after watching the lecture, increase the length of the lecture that the students watch and take notes on, and D, increase the number of students assigned to take notes on a computer. So right off the bat, we can probably take out B and C, because changing the length of the quiz that they take or changing the length of the lecture that they watch, it doesn't really help us with replication, because we still have the same variables or the same amount of students in each group of note-taking strategies. So for replication, this isn't really what we're trying to test. So we can take out B and C. So between A and D, where we increase the number of students to both note-taking strategies, versus D, where we increase the number of students to just assigned to taking notes on the computer, we would want to choose A, so that we can increase replication for both note-taking strategy groups. So to increase replication and improve the outcome of our study, we would want to put more students into both note-taking strategy groups. And so we would choose A for question 5. This is a brief case study on the different variables, different terms that you would go into for an experiment, and you would be going more into these different like independent variables, dependent variables, replication, and things like that in exercise 2. So if we go back into Simutext and say we want to go to section 2 for SimBio, when we're here, it's going to load for a little bit. We're going to be looking at the symploids. So symploids are these little creatures that yes.
We can just see the Word doc. We don't see the Simutext.
Oh, really? Okay, one moment. How about now?
Yep, got it now. Thank you.
Awesome, great. So for section 2, we're gonna try to save the symploids. So the symploids live in the town of Idyllic, and they are somehow getting sick, and we don't really know why. We're trying to test between either different variables to see if it's due to the herbicides that are in the grass because they feed off of grass, or is it because of the pests that live in their area? So for section 2, you're going to be making setting your hypothesis, setting your variables, and then testing out through replication and making your separate plots of land to see which variables, or just test your hypothesis and see why are the symploids getting sick. So if we go to this section or slide 2, again, you're going to have questions that you're going to answer that you can check your answers to, your graphs to see, compare like the symploid disease versus different variables like different worm infestations versus temperatures, or zapweeds, which is the herbicide, as just a little background before you start setting your hypothesis. More graphs, more questions. Based on the different colors on this graph, the population sizes differ. So the darker the graph color, the more symploids live in this plot. The symploid disease rate can be adjusted if you click on this next box, and disease rate, death rate, all of that. And so you can set your hypothesis, and let me just show you how you can set up your experiment. So these 2 slides are practice setups for slide 6 and 7. But say if we wanted to design our test, we can add study plots. So the max amount of symploids we can add are 60 symploids. They need plants to survive, so we can add just as much plants. And you can either add just herbicides, or both herbicides and parasites, or just parasites. And say for our control, we would want to have both symploids and plants, but no herbicides and parasites. At the bottom here, you can type in the name for your plot to indicate what are you trying to study. But that is the brief setup for section 2. Is now 9:24. Let me give you 25 minutes to do section 2 in your groups, and I will see you back and just check up on you again at 9:40. Okay, did anybody have any questions before then? Okay, awesome. Hey, I am now opening the breakout rooms. I'll see you all then. Okay, hello. I guess we can start with group 1. What did you guys think was the reason why the symploids were getting sick? You can talk about like your hypothesis, and you can just go through your results.
Well, first, I tried to do it where it was just the herbicides affecting them, and then like I found out that that wasn't what was affecting them. It seems like on my next experiment that it's both the herbicides and the parasites together that
Oh,
seem to be affecting them, and so that's what I put
mhm.
as my final answer. But I never tested just the parasites by themselves, so that maybe that's in there too.
Yeah, okay, sure. It sounds like you got to test out one hypothesis and then move on and see if maybe it was both herbicides and pesticides, and then test that out. But good. It sounds like it worked out well, where now you can just test if you wanted to see if it was like either both, or is it just like pesticides. But okay, great. Sounds good. Sounds good. Group 2, did somebody want to talk about what you guys found for your studies?
I think I'm group 2. And so I did the same thing as Tyler, where I just did the herbicides in the very beginning. And then I actually saw that that wasn't right. And so then I switched to just pesticides. And I found that pesticides alone also seem to be the cause of the sickness and the death. And so that was sort of the conclusion.
Okay, awesome, cool. It sounds good. So it seems like it could be either a combination of herbicides and pesticides or just pesticides, but great. I think that's good for replication, just testing out one variable at a time. So I like that you tested just herbicides first and then pesticides. So good job. Okay, so for our last group, group 3, did somebody want to talk about what you guys found there? Mm.
So I tested, my control group was neither herbicides or parasites. And then I also included another study plot where there was just parasites, and then another group where it's just herbicides. And then I found that the group that had parasites were the ones that got the most sick and had the highest death rates.
Okay, good to see. Sounds good. It sounds like you did your replication right, where you had your herbicides in the plot, pesticides in the plot, and it sounds like it's like the parasites, and it sounds like it's parasites. So it looks like everyone's been doing good. I've been looking on Simutext, and I'm happy with all of your progress so far. And but great, good job with exercise 2. And again, as a recap, once you're done with exercise 2, you don't have a post lab. Everything that you've done in Simutext is what's due for lab 2. So you don't have to turn anything else in. So just make sure that for every single question you put the submission, you choose an answer, and then all of that. But let me just share my screen. So that is what's due for lab 2. It's just Simutext, exercise 1 and 2, and doing those 2. But for next week, we don't have lab because of President's Day. So we are going to be meeting the week of February 22 for lab 3. Again, we're using SimBio, but then we're going to be looking at different populations, looking at predator-prey relationships in Isle Royale. So that is what's going to happen for lab 3. There's also a pre-lab quiz for that, but it's not due until 15 minutes before we meet for lab on the week of February 22. So basically, once you're done with SimBio for today, lab 2 is done, and you just have to do a pre-lab quiz for lab 3 that's due the week of. But I won't see you all until like 2 weeks later. So I think that is pretty much it. And thank you all for joining. I hope you have a good rest of your day.
Thank you.
Thank you.
Thank you.
Thank you.
I have a question.
Sure.
Uh,